Number 30, part B on page 150 says, suppose the boat is moving at a constant rate of 4 feet per second. We are asked to determine the speed at which the winch pulls in rope when there is a total of 13 feet of rope out. So the boat is moving at 4 feet per second. So that would be it's moving this way. So this side is changing by 4 feet per second. We want to set up a triangle. As this moves in this way, this side changes. I need to call it a variable. I'm going to call it A. Somebody wrote a 5 in there. Don't worry about that. As this gets pulled in and this boat moves this way, this distance here does not change. It stays 12. We can leave that as 12. And as this moves this way and it gets pulled in, this side here changes. It needs to be called a variable. I'm going to call it C. So again, any constants that we have, anything that doesn't change through the problem, we can leave as a number. Any variables we have, anything that change, we need to call variables. So A squared plus 12 squared equals C squared. We are taking the derivative with respect to time, so that's going to give us 2A dA dt. Derivative of this is 0. Derivative of this is 2C dC dt. It asks us to determine the speed at which the winch pulls in the rope when there is a total of 13 feet of rope out. 13 feet of rope out, that would be C. We are looking for the rate at which the rope is being pulled in. We are looking for dC dt. And we need to know what A is. When this is 13 and this is 12, you can use the Pythagorean theorem, plug in 13 for C, or you might remember 5, 12, 13 is Pythagorean triple. And A is not, or I'm sorry, dAdt says the boat is moving at a constant rate of 4 feet per second. So side A is getting smaller by 4 feet every second. dAdt is -4. Negative because the side is getting smaller, 4 because that's the rate at which side A is changing. So -20 times 2 is -40 equals 26 times dC dt, and then we can solve for dC dt. -1.538. Negative because side C is getting smaller. This is the C dt. C is a side length. Side length is measured in feet. T is time, which is measured in seconds in this problem.